Hey.
I love writing meeting notes. Said no one ever. All right. Hello one, hello all. I appreciate everybody for coming in and joining me again. Welcome back to the stream. We are here streaming, teaching ourselves some computer science and studying some programming. Yes, we are 3 away from 2100. 2100. I hope we'll probably hit that today. So awesome. We'll look forward to that today. All right. Thank you guys so much for being here. Welcome into the stream. I hope you're having a wonderful day so far. Welcome back, one. Welcome back, all. Let me know what you guys are working on. Hopefully you guys are coming up on summer break for a lot of you guys. Let me know what you guys are doing, what you guys are studying. Okay, hold on, since you have a... Using a Gaussian distribution. Add that. Okay. Hello, everybody. Sorry, I was reading something. I'm taking some final courses this summer to finish my bachelor's. Nice, Brayden. How do you work and then code at night, bro? I'm an animal. What can I say? Dude, let me tell you, it's hard. I don't do anything else. I go to work, I come home, I code. I go to work, come home, and code. On the weekends, I finally get a little bit of a break. But I'm really, investing this time while I'm young here and have the ability with little responsibilities and to invest in myself, in my education, and into this YouTube channel and whatnot, and see what happens. So, yeah, got to do some dumb courses like public speaking and Spanish. I should have taken them early in my degree. I got those over with at my freshman year. Actually didn't have to take a second language course in college. Okay. Okay. Okay, let's get into this. So today I want to build a new project. What do you know? We are building projects left and right. So let's see how far we can get in 2 hours. And if we, yeah, I have a second screen now, Tim. I pulled my, I had a second monitor just in my closet from when I used to game. And so I pulled it back out and I put it up in vertical mode, and it's been pretty nice for having the chat over there. Are you coding for YouTube or for a software engineer job? You know, honestly, a little both. I didn't expect, honestly, I did not expect at all the YouTube channel to gain any traction, let alone over 2,000 subscribers so far. Yeah, so it's just, it's just kind of a cherry on the top. I didn't realize that I could have this potential avenue, of my portfolio, I guess. So, yeah, it's pretty cool. Hey, Fan! Welcome! Hello, bro! Yeah, we've been learning React. I'm taking them for the last term of my bachelor's. Oh, wow. Gonna be in the class with a lot of freshmen, Braden. Okay, let's get into this. So, oh boy, we want to build a new project here. So let's do this. We're gonna open up a terminal. All right, here we go. New project. Let's cd into repos. ls here. These are all our repos. Let's go make dir. Make dir. Make dir. We'll call this SpectroSim. I like that. SpectroSim. And then let's cd into SpectroSim. Okay, let's code here. All right. Here we go. So, we are in. Let's go ahead and get init on this bad boy. Or we're going to Python 3 venv. What's the Python 3 env command? Python 3-mvenv. All right. Oh, we need something in here, huh? Oh, yeah. Okay. Let's go get let's go touch readme.md. Let's go get init, get add, get commit, first commit, SpectroSim. Okay, now let's go ahead and set up a repository on GitHub. SpectroSim, public, create repository. All right, now we're linked up. Okay, let's go get branch or checkout -b dev. All right. Let's quickly go here. Let's go Shift Control P. Command P, yeah. We want to select our VNV interpreter here. All right, now we're in our virtual environment. Okay, I'm gonna go pip install numpy. I'm gonna go pip install -- upgrade. Cool. All right. New project coming up. Well, I don't have my chats aren't coming through. Why aren't the chats coming through? No! Where are you, chats? Copy. Let's see. Huh. Oh, it's not even coming up on YouTube chat. Something's not right here. Oh, that's why. All right, let's get some different things here.
You know how a few changes on your website can somehow take weeks to ship? With Framer, you know how a few changes on your website can
Bruh, to replay the ad? Seriously? Come on. All right. All right. Now we're working on a new project today. Hopefully within the next, we can put this together in the weekend. I think we should be able to put together fairly quickly, at least get the working simulator of it here within this streaming session. If we move quickly and we can sort this out. Now I'm not as prepared for this one as I was for my chroma plot. On the chroma plot, I had a lot of things.
Premium and still gets ads.
I don't have premium. I wish I did. No, I don't. But I'm a cheapskate. If it's not broke, don't fix it. For every one of you, there's thousands of unattractive people doing the same thing that get less than 2 viewers. Yeah, exactly, dude. Okay, hold on. Let's get caught up on the chats here. Sorry. I need to change my...
Sickapoop says, what is SpectroSim?
All right, we'll explain that here in a second. Hold on, let me change my title here. I have the wrong. We're not doing React today. Sorry. Edit video.
Shori says, good morning.
Hey, good morning to you if it's morning for you. We're doing SpectroSim, a All right, and then let's change that to...
Skewichis says, are you attracted, bro? Skewichis says, no diddy.
Those are funny, bro. Okay, there we go. All right, we got the title changed over. Okay, let's get caught up here on the chats. As crazy as sound, people will watch people who look good. Streaming could become your main income eventually. You can make a lot of money. AZ says, that'd be crazy. Oh my gosh, you guys are funny.
Shori says, yay Tim, I do not understand why do we get ads we after purchasing premium.
Streaming could propel you to your first software engineer job. Just need an Amazon manager spawn in here. Yeah, you never know who will come in here. You never know, right? For every one of you, there's thousands of unattractive people doing brutal. Not hitting on you, just saying the truth of it, really. I stream only my hands on my keyboard and screen because your boy AZ is. No, you're... Bruh. But I can outcode most TypeScript when I play games, so watch me. Nice, dude.
Understand why do we get ads we after purchasing premium?
Yeah, if you still have, you can make up for that difference. Bro. Y'all are trolling. Hey Harry, how's it going? Send a body. How's it going, dude? Welcome. If you guys are here, leave a like on the stream.
Tim says, are there any famous coding YouTubers who stream?
I think there's like the Prime guy.
Skewichis says, are you a baddie bro, fully diddy bro?
Bro. Okay, let's get started here. So SpectroSim is going to be a spectroscopy simulator, right? So we need to do a little bit of explaining here. So let's do some background work and now let's get into this. So let's do a whiteboard here. Okay, so with spectroscopy, so think of it like this. You have some light source. Right.
Says, yo.
Hey, you have some light source, right? And then this light source shines through some sort of, like, at a concentrated level, through some kind of, like, prism, right?
As says, smash that like button.
This, and then it gets concentrated down at a various wavelength, lambda, right? So that's the representation of wavelength, is this Greek character lambda here. So this is wavelength.
Skewichis says, be zesty for views, bro.
Right? So this is going to be our x-axis. And then you shine this through a solution. Right? There's a distance here, right? Pause.
Skewichis says, how easy is your life, bro? How easy is it to get girls? Do they just come to you? Low-key kind of curious. As says, one more sub.
One more sub. There's a distance here, like 1 centimeter. And then this gets output at a various intensity. Right? And so then you read this here. And then there's all sorts of factors like concentration. Right? All that kind of jazz. So how do we actually calculate this at a certain wavelength? So we first need to determine some wavelengths to use. So let's do like 100, 200, or 100. We could do like 200, 300, or we could just do 100 through 1,000 to get 10 points, right? So, so the wavelengths are going to be a range of up to from 100 up to 1,000.
Says, I know you can hear these comments, bro.
And 1 with a skip.
Says, lol. Tim says he left his room once and got a wife in 2 minutes.
So from 1 to 1,001 with a skip of 100. So that's going to be our lambda. So this is going to be 10 x data points. Right? And so our y-axis, so we have our x-axis, which is going to be lambda. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? This is lambda. And then what we're going to have here is absorbance.
Explain it better as to what this could be used for. Skewichis says I bent that.
Yeah, so basically you can determine the absorption of certain concentration levels at various wavelengths. And what this is able to tell you in some like real world instances is like, various properties of solutions and interactivity of those solutions with when you excite the molecules within them, to and whatnot. And so what you can do is you can create like, polarizing filters or things along those lines with this similar kind of mindset, where you can understand what kind of compounds or, elements on this earth can block certain features of light at what wavelengths. And so, that's where you can do a lot of different things with spectroscopy. Like we can look it up, like what is a real world case for absorbance?
That sound interesting. As says spectroscopy is measuring the shadow of micro stuff to identify it from the silhouette.
No, not shadow. You're measuring light intensity.
Bro, stick to getting girls. Leave comp C for the nerds, bro.
We're double dipping here, Skewy Chase. So a real world example of a solar energy conversion, right? How much energy when an object is hit with a ray of light, and if there's any like red light reflected, like it's giving an example of a red light being reflected off of an apple. How much solar absorption does an apple have, or various other compounds have, and you can use these to come up with various like things like materials or products, that have heat resistant properties or various UV resistant properties. It's very much to deal with, what kind of interactions and do these have at various wavelengths for light, and how these compounds block them with their constituents within them. So you can do like phototherapy in medicine is an example, right? Solar conversion, all these different types of examples. So absorption spectroscopy here is spectroscopy that involves technique that measures the absorption of electromagnetic radiation as a function of frequency or wavelength due to its interaction with a sample. The sample absorbs energy, photons, from the radiating field. The intensity of the absorption varies as a function of frequency and the variation of the absorption spectrum. Absorption spectroscopy is performed across the electromagnetic spectrum for various wavelengths, right? From 400 nanometers to like 750 nanometers.
Do you actually get girls, or are you capping, lil bro?
I have a girlfriend, man. I've had a girlfriend for like 4 years. I'm dedicated to the code.
As says trolls, go home.
Anybody want to be lucky number 2100? We're one sub away. Seems like Skewy Chase has got to get his priorities straight. He's too focused on the ladies. He needs to be focused on the code. Yeah, let's keep it to the programming here. Okay, right? The frequencies at which absorption lines occur, as well as their relative intensities, primarily depend on the electronic and molecular structure of the sample.
2100, let's go, boys.
2100, come on!
2100.
One away. The frequencies also depend on the interactions of molecules in the sample, crystal solids in the structure.
Head, if you know what I mean, Mike.
That's for sure. Okay. And then we plot, so maybe we should do, that's okay. So then let's see here. So I have some notes off to the side. So to calculate this absorbance, right? Absorbance is calculated at some wavelength.
Distraction unless they are digital. This is not gonna look good on a digital footprint. I am saying for pure shock value BC, I'm bored.
If you're bored, then open your IDE and start coding. For real. All right. So the wavelength right here, right? So this is called Beer's law, right? '21, let's go, boys! You guys are awesome. Thank you truly for 2100. Let's go. 2102. Boom, boom, boom. Okay, so we got Beer's law here. So Beer's law is some constant. So it's some constant at some wavelength. right, times L times the concentration. So what are these things? This is absorbance, right? This is the max molar absorption at Y max, right? Or no, sorry. Molar absorption. So this is molar absorption. Hey Davies, how's it going? Thanks for jumping in on Twitch. Okay. Path linear. Okay. So let me ask here. Okay. AY. So I'm trying to look here at some of my math. Okay, so let's think about this. So I'm going to create, let's go here, let's go get status. Okay, so let's go make their classes, cd classes, touch compound dot pi. So let's go ahead and create this class. So this is going to be a compound. Right? When we initialize the compound, we're going, right? When we initialize the compound, what's some things we need for this compound? Let me look up VS Code hotkey for lambda. If I say how do I want to structure this? Let's think. Okay. So each compound is going to have a lambda max. So where can I Okay, so you have a lambda max. So then we're going to have a, whatever this symbol is. Right? Okay, so we have lambda max, we have E max for the specific compound. Self dot the lambda max is equal to lambda max, and then self dot E max, right, is equal to that. Okay, so we initialize our class that we want. What is Gaussian distribution? Exponential function where the mathematical function that raises the constant to the power of e. And probability through an exponential modified Gaussian distribution, also known as parameters are mean of the Gaussian. Okay. Okay. Let me move this over here. Okay, let's see here. Okay, so then I'm going to come here. Let's set up a database. So let's go, this is going to be just JSON. Okay, we're going to simulate some JSON here. So I want to make some JSON. So this would be quote methyl blue. Methylene blue. It'll be a dictionary. We're going to have a Emax and also a lambda max, right? How can you, I need an example of JSON. How do you, JSON example? multiple data JSON example. Okay, so just a list of dictionary objects. Okay. Equal to so let's just use this example. Okay, so let's just call these lambda max. And then let's just call these like lambda max. This will be epsilon max. I spell epsilon. Okay. Okay. Epsilon max. Okay, and then you have a self dot. Obviously, you're gonna have a name. For the compound, you're gonna have, so the name is gonna be a string. This is gonna be int. This is also gonna be an int. Okay. Let me turn it back on details. Now that dude stopped spam and I can turn it back on. Oh, maybe not. Maybe. Whatever. Okay. Okay, we have name. It's gonna be for our first one. We're gonna part methyl blue. Our lambda max. It's gonna be lambda max for methylene blue for my source here is 665 and its epsilon max is 1500. Okay, and has a sigma of 20. Okay. So that's a single compound. Instead of using JSON, is JSON fast? Like, how fast is it compared to just a Python dictionary? Like, getting this data. Right? Like, what if I just had the name of methyl blue as the key of the dictionary in Python? So what if I did this, just data .py rather. Took this dictionary out of here, put it here, and provided a key of so we say database is equal to a dictionary of dictionaries, where this is our each dictionary inside here is a compound and the key to this individual dictionary so you have a dictionary with quote methylene blue with a value of this, right? So what do you guys think? Is there any benefit to using this or JSON? What do you guys think? So then we can just quickly access by key within database, get quick lookups for all the data. Okay, and it's got a self dot sigma is equal to sigma, and then it's going to provide a sigma value here, which is also an int type, right? Okay. Okay, so then compound. So I'm going to say okay, so we just have a compound here and then this guy here. So let's go to a main file here called main.py. Bring this out. Drag this over. This over here. Okay. So we're going to do this. We're going to say so we're gonna have a list of, so let's go like this. Let's do import numpy as an MP, and we're gonna say import pip install map plot. Okay. Plot as plot. Okay, so we got NumPy, we got matplotlib. So let's first say a range of let's create let's say from classes import compound import compound. Let's say from database dot database import database. Okay. For compound in database, we're going to generate a list of compounds. Compounds, we're going to say we're going to create a new compound class for data in here. Compound equals to this generated compound. Oh, is this a keyword? We're going to have data dot or data name. It's going to be the name here. Data, we'll say that the lambda max is equal to the data lambda max. And then we have epsilon max is equal to the data epsilon max. And then we have the sigma is equal to the data sigma value here. So that'll generate the compound that we need. And then we're going to append that compound into the list. So we're just getting the singular compound right now. We only have one in there. I'll quickly just get a repr here, define or I'll say stir I guess I don't need that, so because I can just call toDict if I want to get a representation. Compounds dot append the compound, and then we're going to say okay. So now if we run this. Name must be type stir, type error indices must be. For every dictionary in there, why can I access I guess let's String indices must be integers, not str. Oh. So this has to be a type of 1. What? Type error, int object not scriptable. Okay, let's figure this out. So, should I just use a JSON file then? Database.json. So if I take this out of here, I go throw that there. Okay, so then I'll say, we'll get rid of this. Come here to main, I'll go okay, so we're gonna say, instead of this, we're gonna say with open quote database slash database.json. We're going to import JSON here. Okay. We're going to open this file in read mode. Right? We're going to say data or content to object as serialized object as JSON formatted stream, right? Dot load to serialize a str bytes. JSON that loads file. Let me print file content here. All right. Let's keep chugging here. So we load the file content, print file content. So let's see if that works. So I just say load content. That loads it, okay. Hey, how's it going? I'm from Mohammed. We're building a spectroscopy simulator, SpectroSim. So this is a list. Content. Okay, let's. Okay, just a single content inside of a list. Okay, cool. Okay, so now let's do this. So we're going to say we're going to compound for row in file content. We're going to create a compound on that row. Given the row here. We're going to say compounds.append compound. And then here, print. So let's see what happens here. There we go. We got the compound created. Nice. So if I didn't put this dict here, it would show it's that it's just the object in memory. Yeah, perfect. Okay. Now we're loading in appropriately from JSON. Nice. That went better than I thought it was going to go. All right. Okay. Next we have for compound and compounds print compound. Okay, next what we should do. Now we want to inside of our class, we're gonna have a def okay, so this is what we're gonna do. Generate Gaussian distribution. We'll say gen Gaussian distribution given self and some wave length. Okay, so to generate the Gaussian distribution, given some wavelength, the formula for the Gaussian distribution is as follows. So, Gauss dist equals to Gaussian distribution at that value is equal to the self dot epsilon max times numpy dot exp. Inside of this exponential function is going to be a negative a negative, we're going to access the current wavelength that we're on, less the self dot lambda max. This is squared divided by 2 times self dot sigma squared. Okay, what do we have here? We have self times epsilon max times numpy dot exponent of a numerator of wavelength less lambda max squared divided by 2 times sigma squared times -1 gives us the Gaussian distribution value. So return the Gaussian distribution value. Okay? So then we're going to call a function also called def gen absorbance of self given some wavelength. And so the Beer's law that we went over earlier this is actually your epsilon. Not epsilon max, but just epsilon at this point in time. Right? So to generate the absorption at some wavelength, you need to give an epsilon right? And the absorbance is equal to the epsilon times some length constant concentration light length solution concentration compound concentration. I'm going to put on here a self or a compound concentration, which will be a float, which is equal to none at the start. Self dot concentration is equal to concentration. Okay. Absorbance is equal to the epsilon times the light length times the compound concentration. We're making a spectroscopy simulator here. I'm trying to see if I can build this. Okay. And so then we're going to return absorbance. Okay. Just like that. So now, in our main py, this is what we got. JSON load file for row and file content compound. We're going to create the compound and add it to the compounds list. This is just to make sure this is not what's going to happen with the user, right? This is going to be a backend query for the user to pull all this information via fast API and then quickly put together a compound class. And then we're going to call this compound's functions. I currently do code as a formulation chemist. I actually started some coding projects that I pitched to my current company and started to work some automation to our current chemical formulations. So, but I would like to go even further and, if possible. Welcome in, dude. Appreciate you for joining. Okay, so then we're going to need to generate, right? So we'll say compound. We'll just say test compound is equal to compounds index of 0, right? There's one in there. Okay. To get this test compound, this is what we're gonna do to this test compound. Well, we need to have a preset determined array of wavelengths. So let's go here and say let's open up a function, a thing here called globals.py. We're going to put on here wavelengths. Is equal to an array of wavelengths, which will be value for every value in range of 100 or 1 to 1001 with a skip of 100. So then we're going to come here and go from globals, import all. Okay, so we're going to say, let's go here and find, we're going to say epsilons, generated epsilons is equal to an array where we say value for every value. So we'll have to just make this list real quick. Then we say for every wavelength in wavelengths. For every wavelength in wavelengths, we're going to generate an epsilon. We're going to call test compound dot generate Gaussian distribution. Right? Given some wavelength. And then we're going to do generated ellipses dot append this value. So I honestly could actually create a let's do this. Let's make a non-public or not a hidden self dot generated epsilons is equal to an array. And then what we'll do is we'll put in a wavelength here. Which is a list object. We're going to say for wavelength in wavelengths. We're going to basically do what we did before. We're going to call this generated epsilons. We're going to do this function, right, on that wavelength. And then we're going to self.append or self.generated ellipses or epsilons. Generated epsilons dot append the epsilon. And so that's it. And then we're going to this is going to return self dot generated epsilons. So then in our main function here, we can just call testcomp dot generate, or we'll say generated epsilons is equal to testcomp dot generate epsilons. As easy as that. Or generate Gaussian distribution. And those will return a list to that value of self dot, and we'll capture that here. Given wavelengths. So we don't even need to capture this because it'll be saved under this. Now I can go like this, print testcomp dot generated epsilons. And then we should get our values here. NumPy.float values. So what if I say for value in self dot generated epsilons, or sorry, test comp, we're going to just print the value. So now that gives us these values. So as you can see, you have some peaks here happening at some various wavelengths. So now what we can do, as simple enough, is just plot these. Yeah, the company's basically filling 2 roles with 1 person. Yeah, they're getting real lucky, let me tell you. Let me tell you. What you guys working on? Let's get some tunes going again. What happened to the tunes? Thanks for joining me, you guys. I'm not really feeling jazz tonight. I want something a little bit more upbeat. I wish we could play copyright music. Like I could play just normal music.
One bean equals $1. You could theoretically count the entire universe worth of stars.
Fred, I thought you...
Okay. Hey, Shadow Knocker. What's going on, dude? Okay, so now we have those. So these are going to be our epsilons. And so then what we're going to need to do is, in our compound here, we're generating all the epsilons, and then we have generate absorbance. So I'll say self dot absorbance. Absorb. How do you spell absorptions? I forgot. What is this sound? Absorption. Equals to array. Epsilons. Say list. Second. Say float. This will also be a float. We say for epsilons. We're going to calculate an absorbance at that point in time, given the epsilon, and then we're going to self dot generated absorption absorbance dot append absorbance, and then we're going to, we don't even need to have the return back to us. Nice. So now we'll call testcomp.gen absorption, right? Given testcomp dot generated epsilons, and then we're going to say for every value in generated absorption, print value. So now so I'm going to also give this a, so this doesn't need a concentration. So I'm going to create another class here called simulate SpectroSim.py, So we're going to initialize this. Given self. This is going to take in a light length. And a, we're going to go here and go self dot, or so, from compounds, import compound. I'm going to take a compound. Which is a compound. This is going to be a float for light length. Yep. And we don't need to pass this in. So I'm going to move this function. I'm going to copy this out, put it into here, back it up. For epsilon and epsilons, we're going to calculate absorbance, light compound. No, I'm going to leave that off, have it stay here like so. That'll stay. Light length, let's call that concentration. Okay, so here, this is what we're going to do. Is it's going to take in a compound and a light source, or light length. So we go self dot compound is equal to the compound provided, and then also self dot light length is equal to light length. Okay. Cool. So then what I'm going to do is I'm going to call a SpectroSim is equal to yeah, similar, kind of like that, light and different light, yeah, kind of. Hey, how's it going? Welcome on Twitch, Ayush2K2, how's it going? We're building a spectroscopy simulator. So SpectroSim is equal to, we're going to come here and say from classes dot SpectroSim import SpectroSim. So we're going to create a SpectroSim object given a light and then test comp. Okay. So what we're going to call is maybe not. Let's delete this. Let's not do that. I don't want to have the class be nested inside, so let's do so our compound gets a light length and a compound concentration and a list of ellipses and appends the absorbance onto itself. So the thing is I have to give a light length here. So generate absorptions given the generated epsilons, the light, we'll say light length equals to 1.0, and then we don't need to give a concentration here because it'll just be self-dot concentration. Right. So we're going to need to set in the compound here. So let's say it's like 0.045 0.045 for a concentration in the compound. So that sets that. And then we generate the ellipses with this, and we generate the absorption with this. And then let's print this. Oh. Okay, let's see. There we go. So as you can see, this is small, it gets bigger, 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 biggest here, small, and then smaller again. So it's a normal curve. You guys see that? Woohoo! It's working. It gets really small, bigger, 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 biggest, small, smaller, even smaller, way smaller. All right, so now, here we go. All the math is done. So the hard part's done now. The simulation is over. We've already simulated it. It's over. So we've done the hard part. So we just need to plot it now, right? So looks Gaussian to me. Yeah, right? Looks good. Okay, so next thing we're going to do is we're going to open up our chroma plot and get reference of what we did to generate these plots. So here, we have frames. So we want to just generate the plot. Okay. We'll just do this as PLT. Okay, so let's go. Plot is equal to plt dot shoot. I'll say, can you show me a simple non-related example for setting up a plot with matplotlib. Plot noise. If I have predetermined lists of x and y values, all right. So marker draws a circle at each point. Style connects the points with lines. Okay, so let's go. Plot dot plot equal, and we're going to put in here for the x values are going to be the test compound dot the x values are going to be these are the wavelengths, right? And the y values are the absorbance values from test comp dot generated absorption. Okay. So then if I just do plot dot show, okay. Nice. Look at that. So, how could I make this line smoother, like for a bell curve? A densely so you just need a lot more values, right? So if we go to our wavelength, our globals, and we increase this to do 1,000 values between 1 and 100, so 1 and 1,000, right? So now if we do this, now it's way more defined. I needed more x values to smooth the graph. So let's do like with a skip of 2. That's still pretty smooth. Let's do a skip of 3. That's still pretty smooth. Let's do a skip of 5. Is this not changing? I think it is. If I do like skip of 25. Yeah, it is changing. Okay. So let's do a skip of 10. Let's find the most amount of points without breaking the kind of curve. So that has a little bit more of jaggedness, so back that off slightly. Let's do skip of like 7. Let's do a skip of, let's just do the 5, I guess. That was good. All right. Okay, so then let's do let's set some stuff here. We'll do the plot equals to quote absorption spectroscopy of test name, right? So if I give a plot.x label of this is going to be the x-axis, these are wave lengths in nanometers, and then the plot.y label is the absorption at lambda. Give me that lambda, where are you? Give me the lambda. Right, absorption at lambda, wavelength in nanometers. Make this go to 3. So label, that's not working. Plot label. Okay, so that's just, let's take this label. We want to go plot.title. Goes this. So absorption spectroscopy of methylene blue. Yeah, absorption spectroscopy of methylene blue. Nice. So can you zoom in? Nice. Vim Motions. No, I've never heard of that before. Would you mind explaining it, Primus? Thanks for coming in, dude. What's going on? If you guys are here, leave a like. We have we did the project. Nice. So look at us. We're able to kind of bust out some projects. Now this one wasn't too advanced. We only had to just do one class, 2 mathematical functions across an array of data of wavelengths to generate y values off of our x values, and then we're just plotting it. So it's pretty simple. It's not too hard to do these kinds of little simulations and chemistry simulations in Python. So we could really expand out our chromaplot.com to encompass, you know, a lot of things. So should we try to merge this onto chromaplot.com or make it its own site of spectrosim.com? Because I would have to buy another domain name for that one. I'm going to be buying like 50 domain names by the end of the year. Or should I buy like a 1737 coders? What are those? What are 1737 coders? John. Hey John, what's going on, dude? I always see that Johnny Sins profile picture. I know it's you. All right. Cool. Look at that. So now let's go ahead and let's add some more compounds to our database here. So let's go online and look up for some information along these. So let's look up compound lambda and lambda, sigma, and epsilon. Database. Sigma profiles database. Hundred. Okay, methane. Okay, what this database here? Okay, we got chemical formulas, compound names, CAS numbers. Let me take a chunk of this and put it in the Almighty and see what it says. What kind of data is this? Experimental thermophysical data for a set of alkene and alkane derivative compounds commonly used in computational chemistry and thermodynamics. Cosmos relative properties. Is there a database online for max and max, epsilon max, and sigma values for compounds. Webbook NIST chemistry. Okay, NIST chemistry webbook, a NIST standard reference database number 69. Search options models, notes. Let's look up methyl blue. Methylene blue. Okay, methylene blue. IR spectrum. Includes data like UV, IR, and more than. Gotta find a database online. Hey, how's it going? Just buy ChemHub at this point. I think ChemHub's taken. Not seeing anything there. PubChem. Let's see, methylene blue. Okay, methylene blue. Says parrot. Oh wow. Got a lot of stuff here. Nuclear formula related acid. Properties. Hydrogen bond count. Complexity.
Choose to lean into it. Every Mazda is engineered to give you effortless control.
What's this ad?
It's not easy being the one
Get out of here.
to keep your operation running. That's why
No.
for you with professional grade industrial supplies.
Unskippable.
Call, click Granger.com.
Oh.
Just stop by. Granger, for the ones who get it done.
Bro. Search compound scrolls spectral information or experimental properties. Spectral information. See, it has it here. IR, spectral information, source of spectrum, about this one? Oh, view the Y-max directly on the spectrum. You can see the max here is at like 1320. Used in physical organic chemistry available from here. Sigma values not found. Okay. Using this weapon to scrape UV whiz. List web book. Methylene blue. IR spectrum. Absorbance. Here. Don't see where you're pulling data from on. Go to UV after provides. Base. From this guy. Viz. Huh. The acetone. I'll click on UV visit. Go aspirin. spectral information. UV spectrum. Max absorption here. So if I go here, let me take this. This is from PubChem on aspirin. Is this the right place? Yes, this is the right place. You're looking at the kind of data you need for UVIB absorption project and entry for aspirin. What you're seeing, the solvent condition is ether. Oh, so you have these various. Max absorption was in ether at 275. Okay, so how can I scrape PubChem
Every project and work management app out there promises that they
for
are
the
all-in-one.
info?
The promise was wearing me down. I've made dozens of software and tool purchases for my teams over
Oh
the years,
no.
but there was
Just prefer what access data. Okay, so if we Okay, so we can physically go pull those via an API. Beautiful soup. Yeah, that's what it's recommending me here. Is to use beautiful soup to scrape the data off of this page. So maybe this is what we could do. What do you guys think about this? Maybe we could have it so that we don't store the database on disk within the project. We instead store, the only thing we store is available compound names to choose from, right? So if we want to store available compound names, then we'll have to scrape the available compounds from PubChem API, right? All the available compounds. But then when they select that individual compound, that's when we will go fetch from the API that compound information. We don't need to scrape and generate our own database really of pre-existing data. It's already there. We just need to go access it when we have the specific compound that we want to access, right? What do you guys think about that? So we just need to have, the only thing on disk we need is then the individual names of the compounds within the database. And then so the user can select the individual name to go fetch on the back end to generate the plot. Right? Let's so I don't need a scraper or need my own DB because I can fetch the info off of PubChem. I do only need the total list of compounds offered on PubChem though. Then when a user selects that compound, it will fetch it from PubChem. Your idea is very feasible. You don't need your own database for the spectral info if you're only pulling data that already exists on PubChem and you're okay with on-demand fetching. You're okay with scraping unstructured data like UV, Max, and IE as needed. But you'll still need to handle. PubChem has millions of compounds, so when you say I only need a list of compounds offered on PubChem, that's a huge data set. Here's why you probably don't want preload all of it. This lets users search for compounds dynamically with autocomplete with this API. Oh. So the response would be all the compounds. So we could have the API give us the closest possible match, provide those to the user, and then allow them to select as it redefines. What do you guys think? Yeah. So it's saying that we can use this API to get partial dictionary, partial just most applicable names given the partial search, and then they can select for one specifically. Use PubChem compound URL is creepy. All right, this is a good place. I think I'm gonna pause for today. So we wrote the program here, which is really nice. Oh, I didn't push it all. Shoot. Oh, I forgot to push and commit along the way. No. Oh, that's troll. Shoot. I added a lot. Oh, crap. That's okay. I wanted to track it along the way, but looks like we jumped the gun and just built it. Bro, I'm bad. Okay, get add all. Oh, I guess I could have added one by one. and then committed one by one. Oh well. Git add, git, commit. Say,
We are Studio Merge, a creative studio.
Git commit dash m. We'll say developed or wrote algorithm for absorption Okay. All right, so that's cool. Let's add on a few compounds then, I guess. I find one here. Okay. Nah, dude, I was about to call it for today. I've been getting really bad sleep, you guys. I've been staying up way too late coding, watching videos. I probably might get on for a part 2 today. Honestly, I'll probably get off for about 45 minutes and then hop back on because I'm bored. So I might as well just jump the gun now and get it over with, right? Take my break now, take my lunch break, and then we could come back and watch the rest of that Tailwind CSS video. What do you think? Should I buy the domain name? Let's see. Let's go to Cloudflare. Okay, let's add a domain name. Okay, let's see what's available. ChemHub. So chemhub.me is available, chemhub.org, .site, .live. SpectroSim is available. Should I pick up SpectroSim, Tim? Should I pick it up here or should I... What do you think, Mr. Tim? You guys gonna... Should I do it? SpectroSim? Or is there a different name we want? Yeah, Yeah, chemhub.org isn't bad. Unavailable. Chem-hub.org. Chemhub info. Not a bad one. Chemhub biz. What do you guys think? Create a poll here. I know, 13 domain names, right?
In a world of rising prices, Nissan is lowering them on our two most popular SUVs, the Pathfinder and Rogue. From our U.S. factories.
Is it an investment, Tim? We're investing $10 in the DNS so we can have a dev job potentially in the future pay for it. What do you guys think? What domain name should we do? What type of DNS should I get? I was thinking SpectroSim, but I don't know. Alright, I think I'm going to do SpectroSim. Because we can add more spectroscopy stuff on there. SpectroSim.com. Sim Spectra. SpectroStack. Absorb Sim, Lambda Lab. Lambda Lab is kind of cool. You can make one domain with multiple subdomains. Heisenberg. Spec Viewer. Peak Shift. All right, SpectroSim it is. SpectroSim.com. Or should I do SpectroSim? Spectra or Spectro? Spectra or Spectro? Plural spectrum. Feels data focus, evokes spectra. Spectra view, spectra base, open spectra. A prefix meaning of spectrum. Oh, come on, I can't decide. Spectra or Spectro? Let me end the poll here. Let me add another poll. SpectroSim? SpectroSim. I can't decide. It's 50-50. You guys suck. SpectroSim taking the lead. Well, what is spectroscopy? How does it? So absorption spectroscopy. Spectroscopy. So spectroscopy, not spectroscopy. SpectroSim. ChemHub. ChemHub doesn't have the .com. I don't want to have to hyphenate it, so I like SpectroSim.com. All right, we own SpectroSim. Woohoo! We bought SpectroSim. Let's go. Nice. I had to pull out the credit card for $10. Yeah, I got the Apple Card notification here on Cloudflare. Hit for 1044. So the thing is we can also we can further expand that project even more and add on many different types of simulations for spectroscopy. There's not only absorption spectroscopy, there's transmittance spectroscopy, there's many other different types of spectroscopy, infrared, UV, all these types, and so we can more generally we can create even more functions to basically do these simulations for us. Right? So next thing up is going to be a front end, right? Front end? Or we might maybe add in a couple, maybe one or two more simulations, so we have 3 that we can add onto the site as a whole. I think having 3 individual simulations of different types of spectroscopy really would show bioinformatics team and employers a lot of whatever. It would show a lot, I think. I'm going to take my my class here. I'm going to throw this in the almighty orb to see if it has any improvements for me. Here is my algo class for generating the x and y value lists. How does my math look? Class-based modeling the absorbance of a compound using Beer-Lambert law and a Gaussian distribution looks solid. Here's a detailed walkthrough of the math and logic. You're modeling how the molar absorbability varies across wavelengths using Gaussian curve centered at the lambda max with a spread governed by the standard deviation, sigma. The formula is mathematically correct. Got you. You're computing Beer's law. Return instead of storing internally for suggestions. Use NumPy arrays for vectorized operations. Sweet. It really liked it. It didn't have anything really to say about it. We wrote some clean, good code, it looks like. For the most part, we maybe need some checks or whatnot. If you guys haven't voted yet in the Whackathon, make sure you guys go vote on the Discord channel for if you're going to be participating in our Whackathon event, which is where we're all going to sit down and probably build a project together, all together live on channel. I'll probably join like a Discord call with everybody, and we'll stream and we'll have fun. And it'll be kind of like a mosh podge of just hanging out and building together. And hopefully by the end of that session on that day that we choose, we'll have a whole new project that we all collaborated on and can put on our resumes together. So I think it'll be pretty cool. So make sure you guys go vote if you're interested in participating in this. So far we have 7 people that want to join, and they're preferring the weekends for the day that we choose. So if we can probably get 15 or so people, I think that'd be really awesome to maybe make like 3 groups, like a front end group, a back end group, and like a support. I don't know. Maybe like I could be the supporter or whatever in between the 2 groups and teams, and we could work together that way. But yeah, it's pretty neat so far. So make sure you guys go vote in these if you want in the Whackathon section of our Discord. If you want access to this information here, or you want to give some feedback on a day you prefer. All right. Woo-hoo! Feels good. I'm gonna give it this here as well. Ooh. And we'll see if it likes this. This will be like our check. Here is my main Pi doing the organization of everything. You're off to a great start. The script reads compound data from a JSON file, models observance using Beer's law, and visualizes the result as a spectral curve. Minor typo wavelengths. Check your spelling. Where testcomp.generate Gaussian distribution. Oh, I have it spelled wrong. All right, we're good. Fix spelling error on wave links global. So we'll go all right, so we just merged dev into main. And we have dev here. Okay, cool. And then make sure everything still works. Sweet. There's our plot. Looks good. Dubs. Dubs. All right. So we just need to allow. So we have a couple of things we need to do. We need to link up or build some sort of front end with React tomorrow. So tomorrow we'll build a front end with React. We'll also maybe in a part 2 later this evening, I'm going to probably take like a 45 minute break. I potentially will come back on unless I fall asleep. And we'll watch the back half of that Tailwind CSS video. So tomorrow in React, we'll build a front end with React and Tailwind CSS for SpectroSim.com. Really cool. And then we'll think about what other algorithms we want to add to this. So I wonder what happens if we alter this concentration like heavily. How does it change our graph? So it's at like it's a little bit past 600. Now if I make this like even larger at like 10, right? What does this do to the graph? Oh, it just increases this value here, the magnitude at which it grows. So I did 0.01. Okay, so you just increase the magnitude at which or the amplitude at which your peak rises for your. Okay, got you. How did I learn Python? Hey, Raul, welcome in, dude. Yeah, I taught myself Python with Harvard CS50P and Python Crash Course. I have the book Python Crash Course right here. Join my Discord, Raul. Link down below to get a roadmap for free of all of my resources, from my notes on Python Crash Course to PDF copies of the book to weekly breakdowns of the courses I take to everything in the Discord for free for you guys. Community events, all that jazz. Yeah, so make sure to check that out. But yeah, I taught myself. I've been learning for about 11 months. Teach myself every single day. But those two are and then I'm posting videos on my channel of the try it yourself problem solutions from Python Crash Course for you guys to go back and just it just helps me to solidify that basic syntax in Python and get some more practice, and then also provide beginners out there with some example problems that are pretty simple and basic to learn from. So today, I think I'm going to sign it off here today, guys. But we were successful in getting our next project number 6, kind of started here. We've gotten the algorithm written for actually generating these absorption spectroscopy plots, which is really cool. So in order to do this, it just consists of two functions, right, to do this algorithm for spectroscopies. Is you have a Gaussian distribution, which is just a way to generate kind of bell curves based on a predetermined formula here. So this formula is the Gaussian distribution formula according to these various wavelengths or these x values, and then these right, and then a max value given for your peak at what will converge into the peak at that point in time, right? So that's what's happening here is we're generating the individual. These aren't the individual y values. These are the distributions, based upon their standard deviation of this individual compound, right? So this is how you get that separation between your 50% quartile and your 25, like your leaves on the ends. Those if you guys have taken statistics courses or whatnot, I haven't taken ones in like 6 years from college, but and then we take those values and determine the y values on top of those. So those give us the general curve of the Gaussian distribution, right? And then we have to factor those values against those standard deviation values into the actual absorption spectroscopy, which is just the standard deviation value, or that not the standard, but the Gaussian distribution value times the length of the light source times the concentration. And so that will give you that y value that then you can plot against a wavelength, and you get this. So as you can see, you have that distribution, you have that lambda max that is being calculating that distribution, and then you're calculating those individual y values and factoring that distribution to your appropriate scale here. So W sigma, right, John? Yeah, that's just the sigma here is the standard deviation basically between relating to this um, this data point or this data that right because they got these values from doing this experiment. We're just recreating it and using math to kind of mimic a distribution, right? This isn't perfect. This is a mathematical like theory in terms of like what you should expect if everything is 100% or whatnot. But the way they actually do this in the lab is you run the spectroscopy or do the experiment, and then you actually calculate out these lambda max and this epsilon max and this sigma deviation. But we're just kind of doing it the inverse way, like we were with our chroma plot, to where we have the known values, and then we use the math to kind of generate a makeup of what the Gaussian curve or the bell curve would look like with these parameters. Now, is it perfectly one-to-one with what you see in the lab? No, obviously, because we're not in the lab. We don't know all those factors. We're only using these three factors to come up with that, right? So, anywho, thank you guys so much for joining me today. Today was super fun. You can check out the code on GitHub. It is available for you guys there. Go here, Git status. So let me add a git touch dot get ignore or touch dot get ignore, and then how can I add pi cache folders to the get ignore. Get rid of the virtual environments. And then here. Add get ignore and ignore. Git commit. Okay. Now let's go pip freeze requirements dot txt. Okay. Add require dash m. Ah. All right, there we go. So we added a get ignore. We ignoring our VNV and also our pi cache, right? That's inside of here. And then we added a requirements txt as well. I don't know, John. That's just kind of well, like when I was reading Pro Git, so this is coming from the Pro Git book actually. They recommended to, like, when you're doing bug fixes or issues or whatever, like things that is like directly, you know, it just says like it's wise to branch off if you're collaborating. That way, if you start messing with, right, because if you start working on main and someone starts adding features onto main and then merges into main and then you try to merge back onto main, then you'll get some conflicts. You have to resolve those conflicts, because your main is behind their main. So then if you branch, I mean, as long as someone still pulls from main, but in that instance, you'd be pulling main from main, right? Like, so it just kind of makes it a little bit more confusing, I think. Right, let's say you check out, you're on main and you're working on it. Someone else comes in and starts working on main as well, but they don't pull, but they pull, but then you keep working and they don't keep pulling as they go, and you don't keep pulling. You're both working on the same branch basically. So when you try to put them back, you have conflict. So then if you had a branch and then they had a branch, they can pull from main to get, and then push, and then you're basically just, I don't know. I think it's just tomatoes to each their own, but whatever way kind of you all agree on, I think, is the general consensus. Like, should we ask the almighty orb? What is the benefit of working on Git branches versus just committing on main every time? Isolation, working on Git branches instead of committing directly on main has been several key advantages, especially in terms of collaboration. Each branch lets you work on a new feature, bug fix, or experiment in isolation. Your main branch stays stable and deployable. Right, so if I go and fix a bug and it actually creates more bugs, and I wouldn't want to have that on main because a lot of, actually, if you start committing onto main, a lot of your deployments, a lot like Vercel and Render, they will auto start to pull from main on your commits and redeploy your project. So if you're committing onto main and you actually are making errors in those commits and aren't testing them or whatnot, then you're deploying bad code maybe. So safe rollback, better collaboration, clean commit history. All right. Yeah, I really wanted to take those couple of days, those 7 or so days that we did a chapter a day, and we read up through chapter 7 of Pro Git. We still have 3 more chapters, but it's kind of more like abstract stuff, like project management and things like that, which is good, but not stuff that's super crucial right now. So we'll come back to it in time. But yeah, the Pro Git, those first 7 chapters, they were confusing, but they honestly like helped me tenfold be able to understand like branching better, commit messages better, issue reviews, GitHub, like what it actually is doing, like syncing up. So just reading through that book was pretty useful. So if you guys want to reference that, you guys can go back to my previous live streams of when I read Pro Git chapters 1 through 7 live on stream. All right, you guys. This was going to be it for me. We have a working algorithm to generate these absorption spectroscopies of various compounds and via wavelength and an absorbance at that wavelength. And it's pretty cool. I appreciate you guys so much for being here and joining me. This was a really, really fun project to get started in building. We have the actual science algorithm of the absorption spectroscopy built. We're going to be adding in some more things such as like UV, infrared, all these types of kind of radiation spectroscopy simulations to add and include on our overarching project, the SpectroSim.com. Woo! So SpectroSim.com is going to house like 3 or 4 different simulations for these spectroscopy things, and I think it'll be a really great kind of maybe like final project before we start really kicking off our search and hunt for dev full-time employment. So thank you guys so much for being here. I'll see you in the next one tomorrow, where I'll be back to learn more, and I'll see you then. Have a good night, guys. Please leave a like and subscribe if you're still here. Have a good afternoon, evening, morning, wherever you guys are. Leave some likes on the stream. Subscribe if you're new. Join the Discord. Tomorrow we'll be back probably around like noon PST, 12 PST. Potentially also, I am interested in potentially maybe busting out the old League of Legends. What? Video games. I am potentially interested in maybe as like a celebration for 2K and just to reward ourselves for all this hard work and projects, and maybe we could fit in like 1 or 2 games of League tomorrow. I haven't played League of Legends in like a year, in like 2 years, so I'll be pretty rough. I was a Kayn main back in the day. I was a nasty Kayn main, a jungle main. I played Kayn, I played Nunu, I played Jax, I play. Who else jungle do I play? I can't remember. I gotta remember. But yeah, so potentially if we're feeling good tomorrow, we'll bust out a little bit of League of Legends and just take a break and do a little bit of gaming for fun at the end of the stream. But so tune in and let me know if you're interested in that. But I'll see you guys tomorrow. Thanks so much for joining me this evening on May 16th, 2025, where we built the back-end algorithm of our SpectroSim simulation of absorption spectroscopy. See you guys tomorrow. Bye, guys.